So now we're going to continue our discussion on the chemical basis of life, moving on to water. So why is water important? You should recall that the majority of our bodies are made up of water. The majority of this earth is made up of water. Why is that? By design. So water has this formula of H2O, so that's two hydrogens bound to an oxygen. These are covalent bonds. Covalent bonds tend to be no overall net charge. However, there are slight charges on the molecule, so the oxygen tends to be more negative and the hydrogen are more positive, but overall there's no charge to it. But because of this slight charge, it's able to form bonds with things. So this water molecule can bind to another water molecule by forming hydrogen bonds between them. And any given one water molecule or water compound can then bind to 4 other water molecules through hydrogen bonds. That same electronegativity, that slight charge, allows it to also bind to other things. So here we have an NH3. Okay, so water can bind to itself. Water can also bind to other compounds or molecules. Because water has this electronegativity and because water is polar, it's able to have all of these properties and allow us to sustain life. So water is a solvent. What's a solvent? Something that dissolves something else, right? So water can dissolve solids and liquids. So you can put salt or sugar, stir it up in water, and depending on how much you add, you will no longer see the solid salt or water, yes? You can take milk and water and mix them up, and you'll no longer see them as being two separate liquids. And so water, though, can dissolve things that are hydrophilic. What's hydrophilic? Those water-loving things, okay? So there are some molecules that are attracted to water. Those molecules tend to also be polar or ionized. Why? Because that gives them a charge. Remember, our ions have that positive and negative charge, and polar molecules like water have that slight electronegativity. So because they have these charges, they can be attracted to water. As opposed to hydrophobic, a phobia, or water-fearing, these things don't like water. Water can't dissolve them. They tend to not be charged. This is our oil, okay? So you put oil in water, and what happens? It doesn't dissolve, no matter how many times you stir it up. You might get it to be smaller and smaller, but you will always see that there's oil in your water. So this just shows you how water dissolves. So this is a salt crystal that was put inside. The water immediately comes to it and starts to take it apart atom by atom, and then the water surrounds it to stop it from reforming, okay? But this is all a dynamic process, so this is constantly binding and rebinding to things, because I'm sure you've also seen if you sit salt there, it can fall out of the mixture. So this is important because remember, our bodies are made up of water. This water allows us to have dissolved molecules in our bloodstreams, okay? This allows us to have dissolved molecules in the ocean to feed the ocean life. Now, remember we talked about water being able to bond to itself and other molecules. Water is sticky, okay? So it's cohesive and adhesive. And adhesive, you should immediately think of tape. So cohesive together, water can bind to other water molecules. Adhesive, other things, water can bind to those. Now, by water holding on tightly to itself, you can see water that appears that this should fall over our cup, right? So you're adding these pennies to displace the water, and it goes to the top, but the water doesn't want to fall. The water is literally holding on to each other, trying to stop it from coming out. Why is that important? Well, again, if you look at our bodies or look at trees, we have to be able to move things around. So our vessels have to carry that water with the dissolved molecules. Well, the water can stick to those molecules. It can stick to inside our vessels to make sure it's going in the correct way. It can climb up a tree, a straw. Those things are helping. Water is sticking to itself and moving around and carrying things that are important with it. Water has this high surface tension. This allows things to float, okay? This allows a duck to float on water. It allows some small insects to run across the water, Okay, so water binds to each other, and those bonds are pretty strong. And by doing so, things can appear to just float on top of it because the water is holding on to itself, and that thing is not breaking through the water. It's just going to slide across the surface. Water has a high specific heat capacity. What is that? Okay, it means water can absorb a lot of heat without changing its temperature. By us being made up of water, our temperature is relatively maintained at 98.7, and this can vary for individuals. However, it takes a lot to raise or decrease that temperature. So our bodies are slow to heat up and cool down because it's made of a lot of water. Or if you put water on a stove, like how long does it take for it to start to heat up? It takes a pretty long time, or even to cool down. When you stick it in the freezer, how often do you go back and check? No, still not cool yet. And then it helps with our cooling. So water has a high also rate of vaporizing, and so we sweat to pull heat from our bodies. This is the water pulling those things apart, and the water can hold on to it without it heating up the water because we know water is slow to heat and cool. And so therefore, we're able to perspire to maintain our temperature. And then the density of water is important too because liquid water is more dense than frozen. How is that possible? Okay, so this is the reason that ice will float to the top of a cup is because our liquid water is usually in disarray, right? No real organization to it, but our solid water freezes in a particular arrangement, highlighting those bonds. This allows it to then float on the liquid water. This is important because if we go back to our ocean life, the ocean usually freezes at the top, and that's it. It floats, and it would actually insulate the temperature and keep things alive in the bottom. If this water wasn't this way and it was at the bottom, we would disrupt their ecosystem and probably harm a lot of the aquatic life. Okay, so in summary, if I say, hey, what two characteristics of water make all of these important characteristics possible, you should say, hey, Professor Burks, it is water is polar and able to form hydrogen bonds, which gives it some electronegativity. So polar and forming those bonds allows water to take on all of these properties. Questions, comments, concerns?